Hi, this is Steve, K8BZ. In this video we're going to go over creating cables for the CAMXL, and the first cable that we're going to want to talk about is the TNC to computer interface cable. In the CAMXL, this is a RS-232C cable, and if your computer has a COM port, it will have the male end of the RS-232 DB9 cable connector. Most computers nowadays don't have those. Most people, if they use the computer as purchased, are going to have to get a USB to RS-232 interface. Those are discussed in the link to the other packet radio videos that I have in the description. But we're going to talk about going directly to a COM port and not using the USB interface. What I did is I actually purchased an expansion card to put in that had two COM ports in it because I use those a lot, so I wanted that in the computer. But I have used the COM port to USB interfaces. They do work good, and if you want more information, check the videos in the link in the description. Now on the CAMXL, they use a DB9 on each end, and there are two types of these cables. Just because it has the right connectors on it, don't assume it's the right cable. One kind is called a null modem cable. It's also known as a crossover cable. And what you need for the TNC to computer interface is a straight through cable. It's going to have these connectors on it, and all of the pins on one end of the cable go directly to the same pin on the other end of the cable. So to determine if you have a straight through cable or a crossover cable, if you don't know, you can use either an ohm meter or a continuity tester and check each of the pins and make sure that pin 1 on one side of the cable matches pin 1 on the other side, and go right through all 9 pins to verify that. If you find any of them go to different pins, that cable is a crossover cable, and it won't work for your interface. Now the next thing we need to do is determine if we're going to use the microphone connector to the radios, or if you're going to use the accessory connector. For the CAMXL, most times this is going to be at a permanent installation. I highly recommend using the accessory connectors. That leaves your microphone connector on the front of the rig available for either a microphone, or in my case I have two cables going up, two with a microphone connection. One is a microphone and the other one is a SignalLink USB external sound card for running some of the sound card digital modes. So once you've determined which one you're going to use, you're going to need to consult the manuals for those radios and find the accessory diagram or the mic diagram. Now we're going to talk about the accessory input because that's how we're going to wire this. This is the accessory input for my HF radio, which is an ICOM 7600. For VHF, I'm going to use an ICOM 7000. That uses a mini DIN connection, and this is the identification of each of the pins. And we also need to know what the pin identifications are on the DB9 TNC to radio port connectors on the back of the TNC. So consult all three of the manuals. Then after you consult the manuals, I take a piece of note paper and I just make a real quick drawing of each of the connectors that we're going to wire and identify all of the pins to simplify the wiring process. Here's the diagram that I made. This is the CAMXL connection on the DB9. This is looking at the soldering end of the connector. These are the pin locations, and these are the identification of the function of each of those pins. Now we're going to go over wiring this for the accessory port on the HF radio, the ICOM 7600. That's a diagram of the soldering end of the 8-pin DIN connector on the back of the ICOM 7600. And then what you do over here is you make two columns, one for the TNC and one for the radio, and you identify all of the pins that you're going to want to connect. You're going to want transmit audio, receive audio, push to talk, and ground at a minimum. Those are the 4 that you need. You can also include some others that are optional. So pin 1 is the ground on the TNC, and that's going to go to pin 4, which is the transmit audio ground on the 7600. Pin 2 is the squelch for carrier detect. That's one of the optional ones, and I chose to omit that, so I have no contact there. 3 is the push-to-talk line, goes to pin 3 on the radio, which is the push-to-talk line. 4 is the CW transmit for transmitting Morse code from the TNC, and I actually connected that to the Brown lead. That has no connection on the radio side. That would go to a connector for the manual CW key. 5 is the receive audio. That's also 5 on the radio. 6 is another ground. That's the bare wire. That goes to number 2 on the radio. And number 7 is the FSK digital output. That's another optional one. If your rig is capable of has a mode button identified as RTTY, then you may want to use this. You can still run RTTY using audio frequency shift keying, but since my radio had that, I went ahead and wired it. So once you know which pin on the CAMXL goes to which pin on the 7600, you pick one of the available colors in the cable that was supplied with the CAMXL and just identify a color for each of those: green, no contact, red, brown, white, bare, and black. Then from there, we'll begin the wiring. Now, this is the DB9 connector that needs to be wired. This is the soldering end of the connector. And basically you want to very lightly tin each of the pins that you're going to use, and if you want, you might as well just tin them all while you're doing it, but very lightly. You don't need a lot of heat. Just melt a very small amount of solder in each of those connectors. Then you want to strip one end of the wire, the cable that is supplied with the CAMXL. Strip a very small portion of the end of the wire and tin each of those also. Now, what I'm using here is a little solder aid that holds these for you, that has little alligator clips on it. And that always helps because you're dealing with real small, lightweight connectors and real small wires. Here we have our diagram, so all I have to do is take the proper color and wire it to the correct soldering connection on the DB9 for the TNC. And here they are. They're all soldered on. Basically, both sides of that are tinned, so you put the wire where it belongs, touch it with a soldering iron, and it only takes a very brief amount of time with the soldering iron to solder those connections. If you don't happen to have one of those soldering aids, real effective way to do it with common tools, just put a rubber band around the handles of some bent nose pliers, and you can hold your work that way and have both hands free for doing the soldering. And after all the soldering is done, what I do is I take a piece of heat shrink tubing. You can run it over the opposite end of the wire and just slide it up, but don't apply any heat and shrink that just yet. Then I put another piece of heat shrink tubing on for the opposite end of the cable, and on my ICOM 7600 it uses an 8-pin DIN connector. This is the complete new connector. This isn't supplied with the TNC. You'll have to find those on your own. They're available on Amazon quite easily. Just do a search for DIN connectors and the number of pins, and there's lots of different sources for those. This is the disassembled new connector. When you slide the connector out of the plastic covering, then these two halves come apart, and this is where the soldering is done. This is the soldering end of the pins here. And I'm just holding those in the bent nose pliers, and again we're going to tin all of these connectors. Just put a tiny amount of solder in the hollow portion of all these connectors. And very fine solder, it works really good. You can slip the solder right inside the hole, apply a little heat to the pin, and it will melt the solder right in the hole. This first one is tinned, and then the others will come after that. Then you want to do the same thing on the opposite end of the cable. Strip some of the cable. Oh, also make sure you put this plastic sleeve on there. That's got to go on before you start soldering the connectors. If that slips your mind and you don't put that on, you're going to have to desolder it and start all over to get that on. So then you tin a small amount of the bare ends of the wires and then connect them. From the diagram we had, we know what color goes to what pin, and the diagram always shows the solder side of the connector. Solder all those up. Then you can slip the heat shrink up where it belongs. Again, don't apply any heat to it just yet. When you're all done, it's very advisable for you to take an ohm meter or a continuity tester and verify each of these connections against your diagram and make sure they still agree. It's pretty easy to put a wire where it doesn't belong, or maybe have a solder bridge across a couple of them. I use small alligator clips here to clip onto one side. I can clip a small alligator clip on one connection, hook it to one side of the continuity tester, and then verify that it has continuity to the correct pin and only that correct pin. If it has continuity to more than one pin, you must have a solder bridge, or one of the fine wires came out in the cabling and is maybe touching another pin. Re-verify all of that before you finish all this up. After you've re-verified that and all of the wires are connected where they belong, then you can go ahead and get the heat gun or heat source, shrink the tubing, and you will be finished with that. This side is easy to connect. Basically, you just put the pins inside the two halves of the connector. They only fit one way. They have cutouts in them, so the pin will only fit one way, and you can slide the plastic thing over the barrel of the connector, and you're done there. Now this other part here is to assemble the DB9. This can be a little tricky if you've never done it before, but we'll go over it quickly. These are all the components. These are the two outer halves of the connector. These are the screws that go through these portions and the nuts that hold that together. This is a strain relief clamp. There are two semicircles here with a hole and a threaded slot, and these are the two screws that clamp it together. These are the two screws that actually screw the connector to the TNC once it's assembled. These metal tabs here are bent at an angle to fit the back of the connector over here. So the first thing you want to do is put the strain relief together, and here it is. You put it on the end over the heat shrink. Now that heat shrink tubing has been heated and shrunk now, so you're good to go, but just assemble that strain relief and just leave it loosely on the connector for right now. After that, you want to set that connection inside one of the halves, doesn't matter which one, they're identical, inside of one of the halves of the outer housing. The front flange of that connector goes outside the front of the housing, and it'll set right down in there. Then slide that strain relief clamp up inside the connector. Let me zoom in on this just a little. There's a lot of reflective glare on this picture, but you'll see this flange fits on the outside of the connector. Slide that strain relief clamp up inside the connector. Once it's up in position and it drops comfortably down into that connector, then tighten the screw facing you. Then you'll have to take it back out, and the screw slot on this screw is on the opposite side, and tighten that. So you tighten that strain relief insulator and then put it back inside the connector. Next, you put on the screws, and those just set on the connector. They're not connected right now. These screws have a dent in the middle that holds them inside the connector. Once the connector's put together, they can't fall out. When this connector is completely assembled, that's where you'd use a small screwdriver and screw it. After you plug it in, you screw it into the TNC with these two screws, and that holds it in where it won't come out. So those are just set on the connector. The tip of the screw goes through a hole in the front of the flange, and the back of it just rests in a slot in the back side of the connector. This one's already set in place, and this one is about to be set in place. After they're both in place, there they are. Then you place the top of the connector over them. There's a little lip here that catches that flange, same as on the bottom. It's a little tricky to get that on without bumping these locking screws out of position, but once it's on, you're good to go. Then you take these screws where you actually screw the connector together, put the screws down through the holes and tighten them with a nut on the opposite side, and there's your assembled connector. Now on the VHF radio, I'm going to use an ICOM 7000. That uses a mini DIN connector. This is a disassembled mini DIN connector. And I've got the penny down there just to show you. This thing here above the penny is the solder side of the pins, and that gives you some idea. That's about a little bit bigger than Lincoln's head on a penny. So that is not easy to solder. There are 6 solder connections on a mini DIN. This is the same connector that was used for the old PS2 mouse devices before the USB mouse. You may be familiar with those. Now, some people have said, well, I'm going to take a mouse cable and cut the mouse off, the old PS2 mouse cable, and I'm going to use that. That usually won't work because the mouse didn't use all of the wires, and they didn't bother running wires to all of the pins in those PS2 mouse connectors. If you happen to luck out, you can test it with a continuity tester and see if the minimum 4 wires are there that you need in the right positions for your radio, but I could not find one that fit mine. This is not easy to solder. I do not recommend you soldering your own unless you have very steady hands and good eyes. 20 years ago, this wouldn't have been much of a challenge for me, but now this would be a challenge for me to solder those. Now, I have soldered some of those successfully. Basically, you do the same thing. You tin the wires, and then solder them together. A better way to go is to go on Amazon and buy a mini DIN cable that has the connector pre-manufactured. Then you cut the cable to the length you need. You identify the colored wires in the cable and what pins they go to on the connector, and then wire that accordingly. That for what it costs to buy those mini DIN connectors, you can almost buy a cable ready-made and just cut one end of it, strip the wires, and tin them and solder them onto the connector as already discussed. So that completes all our cables. We talked about the computer interface cable, the straight-through DB9 RS-232 serial cable, the HF cable that was assembled, the VHF cable that was used from a pre-made cable, the power connector. Now, what I'm doing on mine is I'm running it to some power pole connections, and it's going right to a distribution block for my power supply through a 1 amp fuse in that distribution block. This did not come with a power supply, so you can use a 12 volt DC power supply. Always verify that it's 12 volt DC. There's all kinds of power supplies out there, all different voltages, and some are AC, some are DC, some are negative ground, some are positive ground. Make sure the barrel of the connector is the negative side of the 12 volt supply and the inner connector is the plus side of the power supply. Also make sure that it's a minimum 100 milliamp rating. If you try to use something that isn't supplying sufficient current to the TNC, it won't function correctly. It'll look like it is. All the right lights will flash sometimes, but you'll have trouble making contact. So they say minimum 100 milliamp, and I might go a minimum 500 milliamp to be on the safe side. You know, don't hook it up to your power supply through a 35 amp fuse either. You don't want to short something in the TNC and have it really destroy a lot of components. Keep it within reason. I go to a distribution block through power pole connectors through a 1 amp fuse. So those are all the connections on the back. This on top is my old Cam Plus. That Cam Plus TNC, multi-mode dual port TNC, is 22 years old. I bought it new 22 years ago this month, and it still works like new. It doesn't have some of the features of the Cam XL. Just put it up there just for a comparison of the connectors. This used the old DB25 TNC to computer interface cable that a lot of TNCs use, but the CAMXL only uses the DB9 cable. And there's the front of the two units. This is the CAMXL obviously on the top, and my 22-year-old CAM Plus on the bottom. So that is all of the wiring you need to get your CAM Plus wired and ready to roll. And in the next video, we're going to get started showing how to actually put it to use and make some contacts and begin going over some of the command settings to make it function the way you would like it to function. So thanks for watching. Please like if you like the video. Please subscribe if you want to be notified of the next video in this series. And if you have any questions that aren't addressed in the video, I'd be happy to try to help you out if I can. Just give me an email at k8bz@arrl.net, and we'll help you out if we can. Thanks for watching.